Alright, 11.2, standard equation of a circle. Buckingham students will be able to write the equation of a circle given the coordinates of the center and its radius. So you'll notice in the last one, we used the Pythagorean theorem to determine the radius because we can always draw a right triangle. And we're going to see that that actually is very common or very, that has this very special relationship with circles. The Pythagorean theorem is used often with circles. So to do this, we're gonna start off by just graphing this very simple circle, something that has a center at 0, 0, so a center at the origin, and a radius of 5. And this is pretty easy to do. We've done this before. So I'm just going to plot all these points, plot the four corners of the circle, if you will. And then remember, I said that you could go back 4 and up 3, or back 3 and up 4, because we can use the fact that it's a Pythagorean triple when we're doing 3, 4, 5s. And so we can kind of get a good sketch of this circle. I'll try my best to draw it on here. I know I'm using the iPad pen, so it's not perfect. But we got this circle. Okay. So it says graph the scenario with the radius drawn somewhere in the first quadrant. So let's go ahead and draw the radius. We'll just draw it in the first quadrant. And I'm not going to draw it with one of the points. I'm just going to draw it like this, some arbitrary point that we don't know where it's at. And it says, with the radius as the hypotenuse, draw a right triangle with one of the corners at the center of the graph. So what they mean here is if we just kind of draw a little right triangle in here like that. In fact, I'm going to go over it in red so we can kind of see this a little bit better. See that right triangle in there? So now use the Pythagorean theorem to write an equation for any point on the circle P with coordinates x, y. So let's think about that. So the coordinate that we're talking about here, we're going to call this P, call this x, comma, y. And the reason why we're doing that is because what we're saying is this point P represents any point along the edge of the circle. Any point whatsoever. So we could actually draw infinite right triangles in here, and the only thing that would be the same is this hypotenuse. Obviously the x and the y would change. And that makes sense because the x and the y coordinate here are different than the x, y here, but the radius is still the same. So we know that this side of the triangle is x and this side of the triangle is y. So let's think about it. Now use the Pythagorean theorem to write an equation for any point on the circle with coordinates x, y. Well, that's not that hard to do if you think about it. We know that one side is x. We know that one side is y, and we know that the radius is r, or in this situation we could say that it's 5 squared, right? Or the radius squared. Because this is just the Pythagorean theorem, a squared plus b squared equals c squared, where x is like your a, y is like your b, and the radius here, the radius is like your c. So it says, now suppose the center was not at 0, 0, and was at another point, like 3, 4, for example. How might the equation be different? Well, the main thing that would be different here is that the distance from the x distance you see wouldn't just be x now. See, this value is just x. It's just anywhere farther to the left we are, or farther to the right or farther left. That's just some x value, and how far up or down we are, that's just some y value. Well, the thing that would change is the center, right? So let's just imagine that we have a center at 3, 4. And I'm going to try and sketch this. I'll just sketch it up here. So if we had a center at 3, 4, that would be here. And if it was the same radius, I'll try and sketch that real quick. Alright, so there's my new circle now with a center at 3, 4. And I want you to think about this right triangle. I'll try and just sketch one in here just somewhere arbitrarily. So now you got to think about how could you identify this distance and this distance algebraically. It's still two sides of a right triangle, so it's still like a squared plus b squared equals c squared. And the radius is the same. I made the same radius on purpose here. But I wanted to show you now, this is not just x. If you think about it, this distance as we go along the circle is some x value, but it's always related to the center here. So this distance, or this point here, if you think about it, it looks like we went back some x value from the x value of 3. So let me just kind of draw it in here. You know this is at 3, 4. So how would we express this distance? Well, it would just be some x value taken away from 3. And so we could think of this as x minus 3. And in the same way here, this is just some y value with 4 subtracted from it. And so we could call this y minus 4. And I know it's getting a little bit cluttered here, but the point here is, regardless of where I put this point on the circle, I'll make it real big. As I go around the circle, that distance is always going to be some x value, right? Some x value, but then we're just going to take away 3. Or some y value, but then we take away 4, right? And that represents the distance of this right triangle. It's always just some y value minus 4 and some x value minus 3 anywhere we go around the circle, because it's all centered around this circle 3, 4. So as we go to write the equation, the whole point is to figure out where this equation comes from. Instead of just x squared plus y squared equals r squared, or x squared plus y squared equals 5 squared, now we can say, well, you know what, that's, instead of x, it's just going to be x minus 3 squared plus y minus 4 squared equals the radius squared, which in this situation is 5 squared. So I know that gets a little confusing, a lot going on here. But this pattern, if you recognize that this is just like your A, this is just your B, this is just your C, this is just the Pythagorean theorem. And then the next step here says, what if we didn't know the center and use the coordinates HK as placeholders? What would the equation be then? And let's go ahead and also, let's say we don't know the radius. So we could say, instead of 3 being the center, we could say, well, h is the x value of the center. So we say x minus h squared plus y minus k squared equals whatever the radius is squared. Because remember, that 5 was just the radius. And so what we have here is this is actually the equation of a circle. And so you see it on the next page. This is where it comes from. The equation for a circle with center hk and radius of r is just x minus h squared plus y minus k squared equals the radius squared. So that whole explanation, if that was confusing, don't worry about it. The whole point is, just wanted to show you where this formula came from. It comes from the Pythagorean theorem. All right, let's do a couple of these together. It says, write the equation for a circle with a center at -2, 4 and a diameter of 4. Now that's tricky, right? Because we don't have a diameter in here, so we got to make sure we recognize that if they say the diameter is 4, what does that really mean? It means that the radius is 2. And so let's just identify what this is. This is your h, and this is your k. The h is always the x value. The k is always the y. H comes before k in the alphabet, just like x comes before y. So an easy way to remember that. And so when I go to write this out, I got x minus, my h value is -2. That's important. We're going to have a double negative here. Squared plus y minus 4 squared equals, the radius we know is 2, so we're going to write 2 squared. And now all we got to do is just simplify this thing. We got x plus 2 squared plus y minus 4 squared equals 4. And so now this is actually the graphable equation to the circle described with the features here. Pretty easy. I want you guys to go ahead and try practice number 1 on your own. Okay, so they said this time the center is at the origin, and that's 0, 0. So that means your h and your k are both 0, and the radius is 3. So x minus 0 squared plus y minus 0 squared equals 3 squared. Well, x minus 0 is just x, and y minus 0 is just y, so we actually end up with that original equation we had on the previous page, just with a different radius, because it's centered right there in the origin. Okay, let's take a look at example 2. It says a circle with a diameter of 14 has its center in the 3rd quadrant. Let's review what that means, 3rd quadrant. We kind of go counterclockwise here. This is the 1st, 2nd, 3rd. So we know that the center is somewhere over here. And it has a diameter of 14. Let's go ahead and just mark. What does that mean? That means that it has a radius of 7. And lines y equal -1 and x equal 4 are tangents to the circle. Write an equation to the circle. Okay, this is a good thinking question, good little challenge here. Let's go ahead and graph these two lines. Y equals -1. Well, that's just this point here where all the values of y equal -1. That's all this means. And x equals 4, that's over here. And this is just all where all the value, all the spots where x equals 4. That's all that means. And they told us that it's tangent. Remember that tangents are right angles to, or the radius is at a right angle, so we know that it's going to go straight down and straight over. And they said the radius is 7 because they said the diameter is 14. So that just means that the center is 7 down here because we know it's in the third quadrant, not up because then it would be in the second quadrant. And we know it's going to be to the left because, again, we know it's in the third quadrant. So I'm just going to go 7 down, 7 over. And actually, if I counted from this center point, that'd be the easiest. Go 7 over, 7 back. So let's just kind of do that here. We go 1, 2, 3, 4, 5, 6, 7. So it's back where x equals -3. Just kind of marking that. And I'm going to go down from there. I'm going to go down 7. So we go 1, 2, 3, 4, 5, 6, 7. Okay, let's mark that. Okay. A couple things about this. If you notice this center that I just marked, well, this is at -3, -8. And that kind of makes sense because if you think about it, remember, I'm going to be touching y equals -1 with the radius of 7, so -1 minus 7 would be -8, and x equals 4 minus 7 would be -3, so it makes sense that the center is there. Let's see, it doesn't say that I have to graph it, but we could just kind of see what it would look like here. We probably can't even fit it all on this page, but we can just kind of get an idea of what it would look like. Yeah, I mean, it would go off this screen. So, there's the circle. But what do they want? They just want us to write an equation to the circle. Well, this is really easy because we know the pattern. The pattern for our circle is x minus h squared plus y minus k squared equals r squared. Well, the h and the k are right there, and we're going to have double negatives. So this is pretty easy. We're just going to say instead of x minus -3, we can just go ahead and say x plus 3 squared. Plus, instead of y minus -8, we could just go ahead and say y plus 8 squared equals, and we already know the radius is 7, so when we go to square the radius, we'd get 49. And there we go. We found the equation for this circle with the kind of the features or the descriptions that they gave us here in the example. All right. So, summary here. It says, describe how you would graph the following circle as if you were explaining to someone who had only a basic understanding of the coordinate plane. So you're going to need to kind of, all they know is, you know, x and y on the coordinate plane and how to plot some points. So give me a description of how you would graph that. Please do that in complete sentences, as well as leave me your question on Edpuzzle in complete sentences. See you guys in the next video.